Hello friends, welcome to our channel. Today we are going to start we are going to discuss about theorem 32 and theorem 33 of and some other applications from the chapter theorems related to circle from the book Ganit Prakash of class 10 West Bengal Board of Secondary Education. In our previous class we have discussed about theorem 31 and some other applications. Now today we are going to start from theorem 32. The perpendicular drawn to a chord which is not a diameter from the center of the circle bisects the chord. This is what we need to prove. Let this is the center and this is a chord. This and this is a perpendicular AD. Okay, so you can write the given part that we have drawn a circle with center O and AB is a chord of that circle, and we have drawn a perpendicular OD on AB. We have to prove OD bisects AB. To prove construction construction OA and OB are joined. Proof. In triangle ADO and triangle BDO, number 1, OA equal to OB because radius of same circle. Number 2, angle ADO equal to angle BDO equal to 90 degree. Number 3, OD common side. Therefore, triangle ADO is congruent to triangle BDO. Side angle side congruency. Therefore, AD equal to BD, corresponding parts of congruent triangles. Therefore, OD bisects AB. Proved. So I hope this is clear to you. Now let us proceed to our next theorem, theorem 33. Prove that if any straight line passing through the center of the circle bisects any chord which is not a diameter then the straight line will be perpendicular on that chord. Will be perpendicular. I have written it in short form. Will be perpendicular on that chord. Now let us draw the diagram. This is a circle with center O, a straight line which bisects a chord AB at D. So this part is equal to this part. It is given. Now we have to prove that this OD is the perpendicular on AB. We have to prove that. So given to prove OD is perpendicular to AB. Okay. Construction. This is similar as before. Proof. In triangle ADO and triangle BDO, number 1, OA equal to OB because radius of same circle. It is given OD is common side. Therefore, triangle ADO is congruent to triangle BDO. Side, side, side congruency. Therefore, angle ADO equal to angle BDO. But angle ADO plus angle BDO equal to 180 degree. Therefore, therefore each angle is equal to 90 degree. Therefore, OD is perpendicular to AB. OD is perpendicular to AB. Proved. Now let us do one application. Application 6. It says the perpendicular distance of a chord from the center of a circle having the radius of 17 centimeter is 8 centimeter in length. Let us write by calculating the length of the chord. So write the length of the chord. So calculate the length of the chord. This is our question. Now the perpendicular distance of a chord from the center of a circle having the radius of 17 centimeter. Okay, so the radius is 17 centimeter and the chord, we don't know the length of the chord. Now this is our center O. The radius is 17 centimeter. Radius is 17 centimeter, and this distance is 8 centimeter. 8 centimeter, 17 centimeter, and this is a perpendicular. Okay, so we know that the perpendicular drawn from the center of a circle to a chord actually bisects it. From the center, the perpendicular drawn from the center to a chord bisects it. Therefore, AD is equal to DB. Now in triangle ODB, this is hypotenuse and this is our perpendicular. So the base DB will be hypotenuse square minus perpendicular square root. That means we know hypotenuse square minus perpendicular square. This is equal to base square. So 17 square. So this is our base square. That means dB square. So dB equal to root over this. (289 minus 64). So dB equal to 15 centimeter. But the chord AB is double of dB. Therefore, AB equal to AD, or we can say double of dB. So this is 2 into 15 centimeter. That means 30 centimeter. So this is our answer. Now let us proceed to another application. Application 7. It has two parts. So this is a circle. This is the center. The lengths of two parallel chords of a circle. Okay, so we have to draw two parallel chords, AB and CD. The lengths of two parallel chords of a circle with the radius 10 centimeter. That means radius is 10 centimeter. Are 16 centimeter and 12 centimeter. So this is 16 centimeter, AB is 16 centimeter, and this is 12 centimeter. Let us see by calculating the distance between the two chords if they are on the same side and the opposite side. Okay, so we have to find, okay, when the chords, okay, these chords are actually parallel, AB parallel to CD it is given, and in this case the chords are in same side. Okay, okay, so let us first do it. So we have to find, this is a perpendicular on AB and CD. Okay, So let me call it OP and OQ. Okay, we have to find out the distance PQ, the distance between two chords. We have to find out this is our question. Now let me first join this and this. Okay, OA and OC. Now in triangle AOP, in triangle AOP, AO square equal to AP square plus PO square. Okay, now AO square minus AP square equal to PO square. Therefore PO equal to root over this. So AO square, AO is 10. This is the radius 10, 10 square. AP, AP is the half of AB. Why? Because we know a perpendicular drawn from the center to a chord always bisects it. So this part is equal to this part. AP equal to PB. So we can say AP equal to 8 square. So this is so PO equal to 6 centimeter. PO part is 6 centimeter. Now in triangle ACQ, sorry, OCQ, in triangle OCQ, this is O, OCQ, OCQ. Now we can write OC square equal to CQ square plus QO square by Pythagoras. Therefore OQ equal to OC square minus CQ square. Now OQ is equal to root over OC square minus CQ square. So OC square is actually, OC is actually radius, that means, and CQ is half of the chord CD, that means 6. So OQ is equal to 100 minus 36 equal to root over 64, that means 8 centimeters. So therefore we need PQ. PQ can be written as OQ minus OP. OQ is 8, OP is 6, 2 centimeter. Okay, so this distance PQ is actually 2 centimeter. Now same question, but these two chords are in opposite portion of the circle. So this is a chord and this is another chord. Okay. AB is 16 centimeters. Sorry. AB is 16 centimeter, right? And CD is 12 centimeter. Now let us join OB and OD and draw perpendiculars from O on AB and CD. Okay. We have joined OB and OD, and we have drawn two perpendiculars from O on AB and CD. Now in triangle OPV, OP equal to root over OB square minus PB square. OB square is 10, as it is the radius. This is 10 centimeter. This is also 10. These two are radius. And therefore PQ is equal to 6 plus 8 centimeter, 14 centimeter. So I hope this question is clear to you. That's all for today. Tomorrow we are going to solve some more applications, and we shall start a new exercise 3.2. Thank you friends for watching my video. If you liked my video, please like, share and subscribe. If you have any query or doubt, you can leave that below in the comment section. Thank you.